So XtremIO is fast, but it's also extremely simple. Let's take a look at how a single virtual infrastructure administrator can actually manage all the tasks that have been given to him as explained in the scenario. So the first thing we'll do is to log in into XtremIO into what's known as the XMS or XtremIO management system. This may not be something that the VI admin might do. We see as we log in that it's actually empty. There is no volumes defined, and therefore there is no compression or deduplication in place. And we have pretty much the whole system to ourselves. So let's take a dive into the configuration tab where most XtremIO management tasks would take place. Take a look, there's no volumes defined. However, happily, we do find that our initiator groups are already been put into place. That's thanks to EMC Delivery, who did their good job when installing the array. So nothing's been defined here just yet, and that just leaves us with the task of jumping in and creating a first data store. So we'll open vSphere and put it into view. So to create a first data store, we will leverage the EMC VSI plugin. We'll pick the menu entry that reads New EMC Data Store, and we'll assign it a name. In this case, it'll be Acme XtremIO Data Store. We select VMFS as the file system, and we select the array we want to create it in. We pick very quickly the initiator group, give the data store a size, and we're good to go. We watch everything happening in XtremIO, and within the short span of a few seconds, that's all happening. Now we wait for vSphere to assign the data store across all the members, all the servers in the cluster. At 1:13 AM, 2 minutes later, we find that vSphere has finished the creation and configuration of the data store, and it's ready to go. With the data store in place, we're now ready to start vMotioning a first service into XtremIO. At this point, we'll bring the perspective of the XMS into view so that we can see what type of throughput starts occurring as the hosts are migrated onto the data store. So we've got 3 servers that we're going to migrate. 2 of them are production databases, and 1 of them is an Exchange server. Between them, these servers are pushing more than a gigabyte per second and about 30,000 IOPS already. In total, that's about 160 gigabytes with a change rate of about 350 megabytes a second. So now we see vSphere kicking into live the vMotioning, which starts at 1:25 AM. We can see that this is a write-heavy workload, which in XtremIO is always dark blue, which means we're at this point writing from the source. Now I'll give you a hint. The source happens to also be an XtremIO array, which is why this is all happening so very fast. At this point, we now see that the workload is starting to turn into some reads, and very quickly into a lot of reads too, which means that in essence all of the servers have been migrated. At exactly 1:30 AM, 5 minutes later, all servers are fully active on this XtremIO array. So taking a quick look at performance, we find that IOPS are exactly at the expected rate, and latencies are in fact very healthy, even at higher block sizes. So it's all very good at this point. Okay, with the servers migrated, we're now ready to get a few desktops going as requested. So we're going to rely heavily again on our new friend, the EMC VSI plugin, to create a couple of new data stores and get everything going. The first data store will store the template, so it doesn't have to be too big. 200 gig will do. We'll also create a second data store, a lot bigger this time, so that we have a place to put the newly minted desktops into. For the desktops, we'll create a 10 terabyte data store because it really doesn't matter. XtremIO is fully thin provision at the back end, so we have the luxury of creating such large data stores without any hiccups. Now we wait for the data stores to be completed, but it is crucial that we have both the template, the source template, and the final destination of the desktops all in the same array to make the most of the technology. A couple of minutes later, at 2:28 AM, our data stores are ready to be populated. So what we'll do now is we'll bring a template VM from another storage so that we can leverage the magic of VAIX copy on XtremIO on the same array. For this, we'll pick an existing template from another array and we start importing the VM at 2:38 AM. This import won't take very long, but as we can see, the array is still busy doing other things with the servers that we imported earlier on already into full production. And so it is that at 2:39 AM we are ready to begin cloning desktops. So with everything in place, it's now time to kick off our cloning. Again, we'll leverage the EMCVSI plugin. We give the base machine a name. We set up the clone count we want, so 150 and not 110 as requested initially. And we're all good to go. At 3:08, cloning has begun. Let's take a look at what happens next. The EMCVSI plugin shine starts with one desktop. Gets that done quickly and out of the way and pushes 2 desktops. And then we see that the array is now doing more than 8 gigabytes a second. This behavior keeps repeating itself. And then we see 4 desktops all at the same time and the array being pushed at more than 10 gigabytes per second. Having realized what's possible, the EMCVSI plugin now kicks off 8 desktops at a time and the array pushes more than 10 gigabytes a second. So let's skip a few minutes. So at 3:11 AM, we're going to let it go and come back and revisit where the whole activity is at. And at 3:18 AM, we find the system peaking at just past 17 gigabytes a second. Achieving this performance is only possible when offloading a clone storage task to an array like XtremIO that does everything in memory all the time. And so thanks to this very feature, we see that the cloning has finished at 3:20 AM with all 150 desktops done in 12 minutes. That's a desktop every 4.8 seconds. Now let's take a look at data reduction ratios, and we see that we have outstanding capacity and capability used throughout the array with 24.3 to 1 data reduction. So think about this. XtremIO is in fact faster than Flash. Within 22 minutes, we provisioned 3 data stores, we migrated 3 active servers, we imported a 24 gig template, we cloned it 150 times, and again, that was all done within just a 22-minute time span. This means that you, as a virtual sysadmin, can go faster too. You use no storage commands, you didn't have to interact with the storage, you used a single tool, the vSphere web client. You had just one scaled out storage array, XtremIO, and you were the one agile administrator making it all happen.